Okay, welcome back. Now we're going to learn our knowledge of how to set up trig ratios to how to actually solve for sides and solve for angles. So before we learned how to solve for sides using the Pythagorean theorem, but that's when we were given two side lengths and we had to solve for x. Now instead of giving two side lengths, I've been given an angle measure. Okay, and that angle measure represents theta. Okay, so again, how do I figure out which one of these three, sine, cosine, or tangent, am I going to use? So now that I know what theta is, I can figure out what the other sides are. The x is going to be the hypotenuse, 18 is going to be the opposite, and this side is going to be the adjacent side. So I know what the opposite side is, 18, and I'm solving for the hypotenuse, so I'm going to use sine in this first problem. Okay, so how I set this up is sine, and I know what theta is, it's 49, is going to equal my opposite side, 18, over my hypotenuse, which is x. Alright, so let's solve this mathematically, algebraically. I need to get the x out of the denominator, so I'm going to multiply both sides by x. I ran out of room. So I'm going to have x times sine of 49 equals 18. Okay, so now how do I get the x by itself? You can't just divide by the sine. You can't just divide by the 49. You have to divide by the whole thing, sine of 49. Because sine of 49 is a number all by itself. Okay, so you can't just divide by the sin. You can't just divide by the 49. You got to divide by the whole thing. So here, x is going to equal, so what I'm going to do is 18 divided by sine of 49 in my calculator. So here you go, I got a little calculator. Going to turn it on. Okay. Now, what's most important about a calculator and trigonometry is that we are working in degrees. In geometry, we'll strictly be in degrees. When you go to Algebra 2, you're going to be working with something called radians. So if you go to the mode of the calculator, you'll see you have two options here, radians and degrees. Since the degree is highlighted in black, I'm good. But if you ever saw it highlighted in the radian, you have to use your arrows, scroll over to the degree, and hit enter. Once you hit enter, you'll see the degree is now in black, and you're good to solve the problem. So all you have to do is second mode to quit out. Okay, so now all I have to do is put this in my calculator. 18 divided by sine. And now I hit the sine button, and notice it already has an open parenthesis for me because it knows that I have to input something else. So sine of 49, I hit enter. And I'm rounding here to my nearest tenth, so it's 23.9. So x is 23.9. Okay, let's try problem 2. Okay, again, the first thing I need to figure out is where's theta. Here's theta. It's 71 degrees right here. Now it determines what everything else is. This side's going to be opposite. This side's going to be adjacent, and obviously the x is hypotenuse because it's across from the right angle. So I don't know what the opposite side is, so that's not helpful. But I have the adjacent side, and I'm solving for the hypotenuse, so with this one I'm going to use cosine. So I'm going to write it out. Cosine of theta, which is 71, is equal to adjacent, which is 18, over hypotenuse, which is x. So now, whenever you have x in the denominator, a little shortcut is you can actually just have these two things switch places. Because it'll work every time that whenever you have x in the denominator, x is going to equal 18 divided by cosine or sine or tangent, whatever it is. You're going to do 18 divided by, in this problem, cosine of 71. Let's take out our trusty calculator. Now, if you clear out of a calculator, you turn it off, whatever else, the mode will never change. So if your calculator was originally in degrees, it will not change again. Okay, so I know I'm safe to just do 18 divided by, this time I'm doing cos, open parenthesis, 71, close my parenthesis, I get 55.3. Now I know some of you are going to ask me, and I'll just tell you now, does it matter if you close the parenthesis or not? And the answer is simply, it doesn't. But best practice is to just close it anyway. Okay, last one. Again, pay attention to where theta is. Here's theta over here. Looks like the right angle. Right angle is not theta. So in this problem, my theta is 75 degrees. Here's the hypotenuse. Here's the adjacent side. Here's the opposite side. Well, don't have the hypotenuse here, so my last option is going to be tangent. So tangent of 75 is equal to opposite over adjacent, which is x. Okay? Same thing, x in the denominator. So all I'm going to do is have them switch places. Take out my trusty calculator. 14 divided by tangent of 75. And here we get 3.8. 0.8. Okay? Now, just really quickly, I'll just open up a new slide. Let's just say you had a problem. Okay, and it was like this. We'll do a sine problem. Let's say this was 10. Let's say this was x. Okay, and let's say this was 30 degrees. Now, obviously, we know how to solve this because we learned special right triangles. But trigonometry works as well. It just doesn't give it to you in simplest radical form. So in this problem, I have opposite. I have hypotenuse. Sine of 30 equals x over 10. In a problem where x is in the numerator, the problem's much simpler. All you have to do is multiply the denominator to both sides. And 10 times sine of 30 is simply 5. That worked out nicely. Okay, but what if I wanted to solve for the angle measure? So if I wanted to solve for the angle measure, we're going to do the same thing and set it up. Okay, except now we're trying to solve for theta. So what is the measure of angle x? So in this problem, x is theta. I don't know theta, but it still tells me which sides I have in relation to it. Here's hypotenuse, and obviously I've got nothing down here, so what does the 6 represent? It's opposite of theta. So I'm going to use sine here. So sine theta is equal to opposite 6 over hypotenuse 10. Okay? And you're all going to say, all right, well, this is simple. We're just going to divide by sine. Okay? And then theta will equal, so let's go to the trusty calculator. 6 divided by 10 divided by sine. And here's the problem. Sine of what? Sine also always has to have something in parentheses. So what am I actually doing here? So I must be making a mistake. And I am. Whenever you solve for theta, you have to use the inverse of sine. Okay? So when you divide by sine, just trying to look for my eraser, you don't just divide by sine in the calculator. What you do is you take its inverse. So the inverse of sine of theta, the inverse of sine, is sine to the -1 degree. So what you're actually doing is when you solve for theta, you're doing sine of -1, 6 divided by 10. So what's here doesn't change, but now you're doing the inverse of it. So where do we find sine of -1 on the calculator? It's above the sine button there in blue. So you have to hit second sine, and there you go, sine of the -1, and we have to put in what's in parentheses. 6 divided by 10, enter, and there you go. Nearest degree, so it wants the nearest whole number. So in this problem, theta is approximately 37 degrees. And obviously, if this is 37 degrees, we're all experts. These are complementary angles. So this must be, quick math, 53 degrees. Okay, last problem, solve for the measure of angle y. So here's angle y, that's going to be theta. What do I have in relation to theta? I have the adjacent side, and I have the opposite side. I didn't put a little cheat sheet here, but you would know that I would have to use tangent of theta. Tangent of theta, which is equal to TOA, opposite over adjacent. So tan theta is equal to opposite over adjacent. And again, I'm solving for theta, so I'm going to use the inverse of the trig function. Sine, cosine, tangent, they all have inverses. They all have inverse buttons right above them. So right here, I do second tangent. There's tan to negative 1. 100 divided by 41. Oopsie. 100. Actually, let's just do that anyway, just in case, so we see what might happen. So, second tan. Can't see. There's 0. Come on. Move up. There we go. 10 divided by 41. Oh, that actually worked. Thought I'd get an error. Never mind. All right. 100 divided by 41. There we go. 68 degrees. So theta here is approximately 68 degrees. And again, since we're all very smart people, and we know these have to be complementary, this angle here would have to be 12 degrees, 22 degrees. Whoopsie. All right, that's it for me.